The number of copies produced by a copier varies directly as the amount of time the copier is operating. If the copier produces 150 copies in 4 minutes, how many copies can be produced in 1 hour? This example is clearly an example of a direct variation because of the statement varies directly in the first part of the problem. And here, before we solve this, we need to properly identify the representation of the independent and dependent variable, which could later on be translated to x and y respectively. As we can see in the first part of our problem, the number of copies produced varies directly as the amount of time. This means that the number of copies is your dependent variable, which is represented as y later in our computation. And it means that the amount of time used in operating our copier or operation time can be represented as our x. Now that we are now sure which is x and which is y, we can now represent this in the form of a mathematical equation. And the mathematical equation for any direct variation is y equals to kx, where k is the constant of variation or the constant of proportionality. Looking into the problem, we will be using the first set of items given in order for us to solve the next. That will pass us through the solution of k first. Again, we could represent x as our operation time or the amount of time the copier is operating, and y would be the number of copies. We know that a copier produces 150 copies, that's your dependent variable, in every 4 minutes. This is to be used in solving for the value of k, which could be used again in solving for the unknown. And per unknown, we are asked here about the number of copies, so that's actually y, produced in 1 hour. But here comes the concern. Take note that the first set of values given tells us a production of 150 copies in 4 minutes, and we are asked about the number of copies produced in 1 hour. It should not be 1 year because they are of different units of time measurement. In short, it is very wrong for us to use 1 for our unknown later. We need to understand that it's given with minutes on the first pair. We are also to represent 1 hour in terms of minutes. So instead of writing it as 1, there are actually 60 minutes in an hour. That's one thing you also need to understand if you're going to solve for variation problems that involves unit of measurements, and definitely for examples with different units of measurements. Nevertheless, we'll be using the first to solve for the concept of variation. We're going to have it here, 150 as our number of copies is equal to k times x, which is 4. So this is the first part in solving this unknown. So we are to solve for k by applying the division property of equality so that we could cancel this out and doing the same thing on the other side. So k is equal to 150 over 4, or is equal to 37.5 or 75 halves. This value of k will then be used to solve the unknown. Take note that we could also represent 37.5 by 75 halves so that we could have an easier solution later. Or of course, you could all just use 37.5. But let me just use 75 halves in our next part, which is the same thing. Y is equal to kx. It's y that we're looking for. Our k, again, I'll be using 75 halves for easier computation, times our x for the second pair. Again, it's not 1 hour, but it's 60 minutes, since the first part of the problem is talking about 4 minutes. Of course, you could also convert 4 minutes in terms of an hour, but you will be dealing with a fractional portion of an hour, or an answer in, or a value rather, in decimal places. So for me to make it easier, I'll be using 1 hour in terms of 60 minutes. And with this, since I used a fraction, it's easier for me to do that. You have 30 times 75, and the product of that is 2,250. This is the result when we multiply 30 times 75. This is now the answer. Or in statement form, we could say that there are 2,250 copies produced in 1 hour, or again 60 minutes. So this is the answer for this given problem. The more you practice, the better the chance to understand math. This is a direct variation statement for math success. Let this K, the constant of variation, be this channel. In other words, the more you practice with your subscription, the better the chance to understand math. Subscribe now.